Today we're going to start reviewing for our Chapter P test for college algebra. A couple things that we want to focus on is what we do with radicals. In this case, we are asked to take the square root of 5x and multiply it to the square root of 10x squared. Keep in mind that we can take radicals as long as they're the same type, in this case square roots, and multiply them back together. We can also do the reverse direction. So in this case, the 5 and the 10, it doesn't really help me to have it split that way. So I'm going to multiply it back together and think of this as 50x cubed being square rooted. Then I can split it up in a better way. So for example, the 50, I'm looking for something that's perfect. A perfect square in 50 would be 25, and it's factored in there twice. So 50 can be thought of as 25 times 2. The square root of 25 then simplifies to be a 5. The root 2 doesn't simplify anymore. So that's the numerical part. Then the x cubed part, we need to think of that splitting it up. And we can split it into an x squared and an x. When we take the square root of x squared, we just get a plain x, and we are left with one x left inside the square root. So putting this all together, the pieces that have been pulled out of the square roots would be 5x, this one and this one. And then the parts that are still inside the square root would be the 2 and the x. All right, with question 2, our rule says if we are taking the square root of a numerator and denominator, we can think of it as one big square root over the whole thing. So I'm going to do that. I'm going to picture a big square root over all of this. I can do that so that I can simplify 147 divided by 3. 147 divided by 3 is just 49. So I'm going to simplify this down to being a 49. When I look at my x's, I have 3 in the numerator and 1 in the denominator. Take 1 off of each, I'm left with 2 in the numerator. When I look at the y's, I have 5 in the numerator, 1 in the denominator. That leaves me 4 left in the numerator. And now I don't have a fraction anymore. It's just a plain expression, 49x squared y to the 4th being square rooted. When I square root each piece, the square root of 49 is 7, the square root of x squared is x, and the square root of y to the 4th would be y squared. For question 3, again we are being asked to square root a fraction. I can't reduce the 7 and the 50, so it doesn't really help me to think of it as one big square root symbol. So I'm going to leave it like this, but I am going to break down this 50. We did this in the previous problem, the first question. We broke it into a 25 times 2. So I'm going to think of this as the square root of 7 divided by 5 times the square root of 2. And what that does is it helps me figure out how to rationalize this. To get rid of this square root of 2, which we can't leave in the denominator, I need to multiply by another square root of 2. The numerator becomes the square root of 14. The denominator, when I take a root 2 times a root 2, that's the square root of 4, which is just 2. And 2 times that 5 would give me a 10. So my simplified answer for that would be the square root of 14 over 10. For question 4, we still are dealing with some radicals, but instead of seeing the radical notation, we are being given fraction exponents. When you are taking your test, if you're stuck on a question like this, take a step back and think of a little easier problem. If I had asked you to take 5x squared times 4x to the 3rd, we would multiply the 5 and 4 together, and we would add the exponents. That's our shortcut. So we do need to add these exponents, and since they are fractions, to add them together, we need a common denominator. So let's go ahead and rewrite this with a common denominator for our exponents. So our denominators, we have a 3 and a 4. The common one would be 12. To convert 2/3 into 12ths, I have to multiply by 4, so we get 8. To convert 1/4 into 12ths, I have to multiply by 3, so we have 3 of those. Now we can simplify this. The 5 times 4 would be 20 for our coefficient. Our x's, when we add them together, we have an 8/12 plus 3/12. We'd get 11/12 for our answer. The last question I wanted to go over with you was this pattern for when you are cubing a binomial. And if you think back to what we talked about when we were looking at this lesson, we said there's a pattern involved here. It has a lot of 3's in it. So if we take a plus b and cube it, our pattern was to take the first term a and cube it. Then we had 3 times the first term squared times the second term. Then we switched that, 3 times the first term to the first power and the second term squared. And then we had the second term cubed as our final piece. So for this example, our a's are really going to be our 3x's, and our b's would be a -7. So we're going to go through, take out the a's and b's, and dump in what we have, which in this case would be our a we said was 3x, our b was -7. All right, and now it's a matter of simplifying. So 3x if we cube it. Most common mistake here is kids forget to cube the 3. 3 cubed would be 27, and x to the third power. To simplify this second term here, we do have to do powers first. So 3x is going to get squared. That would turn it into 9x squared. Now we have to take 3 times 9x squared times -7. That should turn into -189x squared. Our next term, again, powers first, so -7 squared would turn into a 49. Now we're going to take 3 times 3x times 49. We should get 441x. And our last piece, we're cubing a -7. That turns into -343. All right, so for today, you guys are going to be doing the review packet, the first half of it, questions 1 through 43.